Today we're going to be talking about the unit rate as a constant of proportionality. Your objective today, I will demonstrate my mathematical ability to identify the same value relating the measures of x and y in a proportional relationship as the constant of proportionality and recognize it is the same as the unit rate in context of a given situation through class discussion. Okay, so for your toolbox, we have a couple words that need to go in there today. First, a constant. Okay, a constant is simply something that never changes. Never changes. So if I'm gonna be your teacher this year. Next year is gonna change, but for this year, I'm gonna be your math teacher. That's gonna be your constant. And you're always gonna have math while you're in middle school. That's a constant. All right. A variable is something that changes. Something that changes. And this could be anything. In math, we relate this to letters like X or Y. Okay? And we're going to use those. Now, the constant of proportionality is just a big, old, fancy word for my unit rate. Okay, remember a couple days ago when we figured out the unit rate? That's all this constant proportionality is. And we're going to represent this by the letter K. Okay, so this is your K. When I talk about what is the K, what's the constant proportionality, that's what I'm looking for. It's simply the unit rate. Now let's see how this works with some of the problems that we have for today. Okay, so I was reading an article a couple weeks ago, and it said, that, and this is kind of the scenario, and so I brought this to you guys to see if we could figure it out. It says wildlife conservationists are concerned that the deer population might not be constant across the national forest. Scientists found that there were 144 deer in a 16 square mile of the forest. In another part of that same forest, conservationists counted 117 deer in a 13-mile square area. Yet a third conservationist or scientist counted 24 deer in a 216 square acre plot of the forest. Do the conservationists need to be worried? Well, for me, I work better if I deal with things in a table. So I made a table for you already about, I took the square mile, so I have the three different measurements. And we're looking at deer per square mile. So when I set this up, I'm going to put 144 divided by 16, and that, when I do my calculations, that'll equal 9. I do the same thing again. I have 117 over 13. Okay, and that again equals 9. And the last one, I'm going to put 216 over 24, and that equals 9. This is like my Y and my X that we dealt with like 2 days ago when we were dealing with the tables and charts. Okay, so looking at this, I can say my unit rate is 9, right? Now let's take the same information onto our next problem. Or it's not our next problem, but the next slide. Keep in mind that our unit rate is 9. Okay, so the unit rate of deer per 1 square mile, remember what we said? It was 9. Okay, now I'm going to ask you, what is the constant of proportionality? And all you have to simply tell me is that K equals 9. Okay, what does this mean in the context of the problem? Okay, it means that, if my pin will write, there are 9 deer for every 1 square mile of forest. Okay, So basically, all this the constant of proportionality means in this problem is that there are 9 deer for every 1 square mile. Now, let's use the same information and see if we can play around with this for just a little bit. I want to use the unit rate, okay, or the constant proportionality of where we found deer per square mile to find out how many deer there are for every 207 square miles. Okay, because we found in that table that it doesn't matter. Every scientist that counted deer counted the exact same thing. In the end, they counted 9 deer for every 1 square mile. So that's what we're able to say. That's the constant. That's not going to change for this forest. Now, so I have 9 deer for every 1 square mile. Remember, that's my K. And I'm going to multiply that by 207 square miles. Because this was 9 per 1. Well, now I want to know how many I have in 207 square miles. Well, let's multiply that out. So I have 207 times 9. Okay, this is going to be 63. Oh, my 3 down here. My 6 up here. 9 times 0 is 0 plus 6 is 6. And 9 times 2 is 18. So I have 1,863 deer in 207 square miles. Let's do the same thing and find it out for 400. Now, this is a little different. It says use the unit rate to determine the number of square miles in which you would need to find 486 deer. So now I'm dealing with deer, and I want to go to miles. Well, I have to do the opposite because this was defined deer. Well, I already know the deer. I'm going to know the square mileage or square miles. So I'm going to take 486. I'm going to divide that by 9. Okay. Well, let's divide that out. 486 divided by 9. 9 doesn't go into 4, but does it go into 48? It does. It goes in there 5 times. 5 times 9 is 45. 48 minus 45 is 3. I bring down my 6. 9 goes into 36 4 times. 36 minus 36 is 0. So there are 54 square miles I would expect to find 486 deer. Alright, let's look at another problem that I think is just as interesting. Alright, so I like to cook, and cooking for me is awesome because, you know, I make a lot of good food. Well, I was watching this show the other day about this French cooking class, and, you know, Suzette and Margot were taking this class, and they want to prepare crepes. Crepes are kind of like pancakes. If you go to the pancake house, they have crepes there. Alright, now it says up here in my directions, let me get my highlighter out. It says that one recipe makes 20 crepes. Okay, and with that, it takes a certain amount of flour, milk, and 2 eggs. They want to know that they already have plenty. They already know that they have plenty of flour and milk, but they need to know how many eggs they need because they need to make 50 crepes. Okay, and they're not sure that they have enough eggs. Now, one of the very first things you need to consider before we can even work with this is we need to figure out what my constant of proportionality is. So if I go back and I look, let's bring this down just a little bit so we can work. Okay, if I remember, I'm comparing eggs to crepes, right? Eggs, remember this word too is very important. Eggs to crepes. So I have 2 eggs for 20 crepes. Okay, well, can I reduce 2 over 10? Most definitely I can. I can reduce that to 1 over 10. So 1 egg for every 10 crepes. And guess what? My K then is 1/10. Okay? My constant proportionality is 1/10. What does this mean? Well, we've already talked about this. This means that I need 1 egg to make 10 crepes. Okay, well, I want to know how many eggs I need to make 50 crepes. Well, remember what we did before. I took 50 times, because this is my crepes, 50 times 1/10. Okay, and I'm going to multiply it out. Well, let me show you something really cool that I think when you multiply fractions, because I'm going to make 50 a fraction by putting a 1 over it, and I'm going to put a 1 over it. Now remember, I can cross reduce. Okay, what is the greatest common factor of both 50 and 10? Well, if I look, 10 is. Well, 10 divided by 10 is 1, and 10 divided by 50 is 5. Now I can multiply straight across, and I get 5 over 1, or just 5. So my answer is I need 5 eggs to make 50 crepes. Okay? Let's look. So that is all this constant proportionality is pretty much the exact same thing. Oh, I have a spelling error there. Alright, let's look at the next slide. Okay, so I just have a couple final questions, just some final food for thought type questions. My first one is, what is another name for the constant that relates the measures of two quantities? Well, if we remember, what is this being called? It should be called the constant of proportionality. Okay, in my proportion, basically, what never changes? It's always going to be the same. Remember, we represent this as the letter K. Now, the other question is, how is the constant proportionality related to the unit rate? Well, quite simply, they are wait for it, the same. Okay, so we've done a lot of work with the unit rate. Now I'm going to just switch the vocabulary a little bit and start calling it the constant proportionality, and you need to understand that they're the exact same. We're not finding them any differently. Alright, make sure you fill out your whisk form. The question on your whisk needs to be about this video. Okay, and make sure you write that on a sticky note on the bottom of your notes so you can bring it to class, and I'll see you in class tomorrow.